Not long ago, running open source AI felt completely out of reach. Now, that barrier has vanished entirely. The question isn't how to run it anymore. The question is where to run it, so you finally stop renting your intelligence.
Exactly. You want to own that cognitive power.
Welcome to the Deep Dive. We are really thrilled to have you with us today. Our mission here is clear. We are mapping out the definitive March 2026 protocol, specifically for deploying open source AI.
We are looking closely at Max Ann's latest guide. It covers running models locally, hosted, and in production. The landscape right now is honestly just staggering.
The defining models of early 2026 are incredibly capable. We are talking about models like Llama 4 Scout.
Yeah, the 17 billion parameter version is a perfect example, and Mistral Large 3 is another absolute heavyweight.
Plus, you have the entire Qwen 3.5 series. These models routinely match proprietary giants like GPT-4 now.
They just do it at a fraction of the cost, which changes the math for everyone.
Okay, let's unpack this. We are going to explore three dominant paths today: local, hosted, and production setups. The goal is to give you two massive advantages: data sovereignty and architectural flexibility.
That flexibility is the ultimate superpower for builders. You completely avoid being locked into a single vendor. You dodge their sudden pricing changes or API outages.
Let's start at the most private level possible. Running these models right on your own desk. We need to look here before even touching the cloud.
Right. This is option 1 in the guide, Ollama. It is the default starting point for a very good reason. Think of Llama like a private version of Netflix, but here you actually own the hard drive and you own the TV.
The appeal of that is incredibly obvious. First, you get absolute privacy. Your proprietary data never leaves your physical machine.
Exactly.
Then you get highly predictable speed and zero per token fees for repeated heavy use.
Plus, as of March 2026, the tech took a massive leap. Ollama natively supports agentic loops right out of the box.
I want to break down how that actually looks. Let's say I need a Python script. Instead of just asking it to write code, I can ask it to analyze a messy spreadsheet. It writes the script internally. It runs that script.
And if it hits an error, it just fixes it.
Right. It realizes it made a math error, it rewrites its own code, and it just hands me a clean chart, all while I am sitting offline on a train.
It makes vibe coding radically more accessible. You are basically having a conversation with your operating system. The model uses your local tools to solve complex problems.
I mean, it sounds like magic, so I have to admit something here. Beat, I still wrestle with prompt drift myself, and the idea of managing my own hardware feels daunting.
Yeah. Prompt drift is a notoriously frustrating reality for local setups. You tweak an open source model slightly to fit your workflow. Suddenly, it completely loses the specific tone you loved yesterday.
It is incredibly annoying. The neural weights just shift in unpredictable ways.
And your hesitation about hardware is entirely justified, too. It brings up the major friction point nobody likes talking about: hardware debt. Local models are not magically free.
Right, your physical computer actually pays the toll.
Exactly. If you want to run a true frontier model locally, something like Llama 4 Maverick with 400 billion parameters, you need serious heavy iron on your desk.
Wait, what does heavy iron actually mean in this context? Am I buying a new laptop or a server rack?
You need massive amounts of unified memory. We are talking high-end Apple silicon like an M4 or M5 Max, or custom rig with multiple dedicated NVIDIA GPUs.
That sounds expensive.
It is. If you try to run Maverick on a standard machine, the latency is physically painful. It might print one word every 10 seconds.
So if I'm running this on a standard laptop today, is the free aspect actually a trap?
For massive models, yes. Standard consumer machines usually max out around 7 billion parameters comfortably. Anything larger becomes unworkably slow. You end up bleeding productivity. You pay in lost time instead of money.
Right. You skip API fees, but pay heavily in hardware and waiting time.
Which is exactly why most builders eventually hit a wall locally. Your ambition just outgrows your motherboard.
And since hardware limits these local setups so quickly, we naturally move to the next logical solution, one that bypasses your computer's thermal limits entirely: hosted APIs.
This is option 2 in the framework: Hugging Face Inference Providers.
I always picture this like stacking Lego blocks of data. It gives you access to thousands of models, but you do it without touching a single server yourself.
What's fascinating here is how practical it is. It is the absolute smartest middle ground for an MVP. You can test DeepSeek-V3.2 for complex mathematical reasoning.
Or you can test Mistral Small 4 for pure speed.
And you do all of this using OpenAI-compatible endpoints.
Let's pause for a quick definition here. An API endpoint is simply a digital doorway where your app sends questions and gets answers.
Because it uses that standardized doorway, it is seamless. You do not rewrite your application code. The code you originally wrote for GPT-4 still works perfectly.
You just change the URL string and your API key? That is incredibly smooth. But there is a very honest trade-off here we must acknowledge. Ultimate convenience always costs money. You pay per request. As your user base grows, your monthly bill grows right alongside it.
You also surrender a significant amount of control. You lose strict guarantees over network latency. And you completely give up strict data sovereignty. The data is leaving your building.
At what exact point does paying per request become a bad business decision?
It becomes a massive liability during high-volume production workloads, when you have thousands of users hitting the app constantly. That per-token pricing scales out of control quickly. It is also a non-starter for highly regulated environments.
Got it. Great for fast prototyping, bad for high-volume or strict privacy. Mid-roll sponsor break.
Welcome back to the Deep Dive. We just covered the mechanics of hosted APIs. But if those token costs are suddenly adding up, and you need total architectural control, you basically have to become the provider yourself. That brings us to option 3, production scale. This is where we introduce the heavy artillery, vLLM. It is a highly optimized library designed specifically for serving massive language models in production environments.
It handles the really brutal math required to serve thousands of users.
Right. And the secret sauce is how it manages continuous batching.
I want to make sure we really understand how that works. Contrast continuous batching with how older systems used to do it.
Older systems use naive batching. Imagine a short order cook. They take 5 orders. They wait until all 5 meals are completely cooked before serving anyone.
So if one order is a massive steak, the guy who ordered toast waits 20 minutes.
Exactly. It was terribly inefficient. Continuous batching changes the game entirely. The AI processes requests token by token. The millisecond a slot opens up in the GPU's memory, it slips a new request right into the processing pipeline.
Nobody waits for the stick to finish.
Exactly. The guide also mentions that vLLM handles quantization seamlessly.
Let's clarify that term for a moment. Quantization means shrinking an AI model's file size to use less computer memory.
It drops the precision of the numbers inside the neural network. A massive model becomes much more manageable, but it still requires serious computing power to run at scale.
Whoa. Imagine scaling to 1 billion queries on your own stack. 2-sec silence.
It sounds incredibly empowering. But here is the harsh reality check about self-hosting. You own everything. You own the cybersecurity, the load balancing, the midnight server crashes.
It is a massive responsibility.
Building your own infrastructure is like building a power plant. It is way harder than just plugging your lamp into the wall.
It is learnable, but it requires serious technical comfort. Here's where it gets really interesting, though. The source guide outlines an incredible hybrid trick.
Hybrid inference. This is what highly resourceful, cost-conscious developers are doing right now.
It is genuinely brilliant. They rent a very cheap cloud VPS, a virtual private server, through providers like Hetzner or Hostinger. They might pay just $5 to $10 a month.
The VPS acts as the digital storefront. It handles the web traffic and the SSL certificates.
But they do not process the heavy AI math on that cheap server.
No. They route the heavy processing securely back home.
Yes. They use a secure encrypted tunnel, specifically Tailscale. They route the API calls directly to a powerful local machine, something like a Mac Mini M4 sitting under a desk at home.
It is the ultimate architectural hack. It completely bypasses the need to rent expensive cloud GPUs. You get the public uptime of a cloud server, but the actual cognitive processing power comes from hardware you already own.
Is building a hybrid VPS tunnel something a beginner should even attempt?
Beginners should definitely avoid it. It is strictly for advanced builders, people who want cloud convenience without paying hourly cloud GPU prices. You need to understand networking and firewall rules to pull it off securely.
Makes sense. Start simple, build the hybrid tunnel only when token costs hurt.
Exactly. You only take on that level of networking complexity when it solves a specific financial pain point.
We have covered the main 3 paths now: local, hosted, and production setups. But to truly understand the landscape, we have to look at the extremes. Absolute zero setup on one end, and extreme local optimization on the other.
Let's examine absolute zero setup first. Browser playgrounds. This is the easiest difficulty level available. Think of platforms like arena.ai, grok.com, or Hugging Face Spaces.
You literally just open a browser tab and start typing.
The friction is entirely gone. Google Colab even offers a free T4 GPU tier. It is an unbelievable resource for educators. Students can run complex Python notebooks at no cost.
But there is a massive glaring catch to all of this.
Zero privacy, absolute zero. Your proprietary data goes directly to whoever hosts that playground. They use your inputs to train their future models.
And your custom environments just vanish the second your session expires.
Exactly.
Let's contrast that zero-friction approach with the absolutely opposite extreme. Edge AI. This is the very hard difficulty level.
It is the bleeding edge of the industry right now.
This involves packaging the AI models directly inside a mobile or desktop app. We see this with Apple Intelligence or Gemini Nano. The model lives entirely on the silicon inside your phone.
The theoretical benefits are incredible. You get instantaneous responses, full data privacy because nothing transmits over the network.
And absolutely zero network latency.
But the technical hurdle to actually achieve that is massive. It is an engineering nightmare. Compressing these highly capable models to run on consumer phones is difficult. You must do it without destroying the device's battery life.
That is the real friction point, isn't it? Thermal throttling.
Exactly the problem. If a phone runs a heavy model constantly, the processor heats up. The operating system forcibly throttles the chip to prevent melting, and your battery drains from 100 to 0 in 20 minutes.
And because of that compression, the cognitive capabilities are usually lower than massive cloud models. There is one final advanced path we should briefly mention: managed cloud solutions.
This is strictly enterprise territory. Systems that automatically scale server infrastructure during massive traffic spikes. Most early-stage projects simply do not need this level of expensive complexity.
With Edge AI preserving battery and privacy, will it eventually kill cloud APIs entirely?
Probably not entirely anytime soon. Running massive, highly capable frontier models will always require significantly more compute power. Far more than a slim piece of pocket glass can physically hold.
Edge is for privacy and speed. The cloud remains for heavy, complex lifting.
They will coexist in a hybrid ecosystem, serving very different specific cognitive needs.
So what does this all mean for you?
It ultimately comes down to a very simple decision tree. You must start with the problem you have. Do not start with the technology stack. If you desperately need strict data privacy, use Llama locally.
And if you need rapid iteration to validate an idea,
You use Hugging Face inference providers. Pay the small token fee for speed.
and if you need ultimate scale and financial control,
Then you look at vLLM and dedicated servers. You upgrade your setup only when the need is real. That flexibility is the ultimate advantage of open source.
that flexibility really does change everything. Beat. I want to leave you with a final thought to mull over today. We spent time unpacking Edge AI versus the cloud. If consumer hardware continues to evolve at this rapid pace, and quantization techniques get even more aggressive, we might see a very strange future relatively soon, a future where the massive data centers of 2026 become obsolete for daily AI tasks.
Wow.
Imagine a world where all collective human knowledge fits comfortably on the phone in your pocket, fully offline, uncensorable. What happens to the trillion-dollar cloud empires then?
The entire power dynamic of the internet would effectively flip overnight.
It really could. But until that day comes, you have powerful tools in front of you right now. Pick one specific problem today and just start building. Stop renting your intelligence and start owning it. Out to your own music.